A molecule of glucose has molecular formula C6H12O6. What is the empirical formula of the glucose? So if you define about empirical formula, so that is the simple whole number ratio of different atom in a molecule. For example, if there is the ratio of C6H12O6, this is 6, 12, 6. So we need to make it the simple whole number ratio. So we can divide by number 2, a common divisible number. For example, 6 divided by 2, that will convert 3. 12 divided by 2, that is 6. And 6 divided by 2, that is 3. Further, we can divide it by a common divisible number, that is 3, and this will be 1:2:1. So here, the carbon is 1, hydrogen is 2, and oxygen is 1. So our correct answer will be B. You can also directly divide a common divisible. For example, if you directly divide with the number 6, so we will get the same ratio, 1:2:1. But sometimes the number is more complicated, so that's advisable to go with the simple divisible number. We're going to move to the next question here. The equations show the reaction between carbon dioxide and hydrogen. So when the carbon dioxide react with the hydrogen, produce carbon monoxide and water molecule. So what has been reduced in these reactions? So if you see that the definition of the reduction reaction, so gain of electron, gain of hydrogen, and loss of oxygen is a reduction reaction. While oxidation reaction is a loss of oxygen and loss of hydrogen and gain of oxygen. That is the oxidation reactions. So we're going to see that what is happening with the carbon dioxide. So from the reactant to the product, the oxygen is moving away from the carbon dioxide. So the carbon dioxide is losing one oxygen. So that's why the carbon dioxide is being reduced in this reaction. So B will be our correct answer for this. The next question is about isotope. We need to find the correct definition for isotope. So if we correctly describe the isotope, so there are 3 main definitions for isotope. So the same proton number, but the different number of neutron of the elements which belongs to the same, like atom belongs to the same element, which have same proton number, but the different number of neutron. Or they have a same chemical property, but they have a different physical property. Or we can say they have a same atomic number, or they have a different atomic masses. So if any statement is according to these basic definitions, so that will be correct statement. For example, the D is our correct statement, the atom that have same number of proton, but a different number of neutron. So that is our correct statement. Which substance is an example of formulations? So formulation is what? A mixture of the 2 or more different substances according to the required formula, that is called formulation. For example, if you want to produce a solution of 2 different metals, so according to the required formula, you are mixing their particular concentration and producing alloy. So that is called formulations. What about when we talk about a macromolecule that has a fixed concentrations, which has a fixed ratio of a different atom in a macromolecule. So that's why that's not formulation. We cannot arrange them according to our required formula. So in the same way, the metal is an element, inorganic compound, they are in a fixed ratio. What about the alloy? We can mix the different substance according to the required formula. So C will be our correct answer here. The next question is about the diagram show the chromatography, chromatogram produced by the paper chromatography. Now, this question is related to the chromatography. And in this question related to the chromatography, so here, chromatographic paper or chromatogram is given there. And in this chromatogram, we have a stationary level, that is the surface of the chromatographic paper, and solvent movement is given there. And what about solute movement distance is given there. And what is the retention factor value? So the formula for retention factor, you should know, that is the distance moved by the solute divided by the distance moved by the solvent. So here, the distance moved by solute is, that is 10 centimeter divided by the distance moved by solvent, that is 15 centimeter, and our answer will be 0.67. So the C is our correct answer here. We're going to move to the next question. The table shows some information about the 4 different types of acids. Which acid is dilute solution of a strong acid? So dilute solution means the solution which has the low number of particles in a given fixed volume. For example, if there is a volume is a 1 centimeter cube, so who has the low number of the particle? That is dilute solution. What about the strong acid? So strong acid is a type of acid. Mostly these are inorganic, for example, hydrochloric acid, sulfuric acid, or nitric acid. So they are completely dissociate into their ions. So what about weak acid? These are mostly the organic acid, which are not completely dissociate into their ion. So some molecules, they dissociate. What about mostly they stay intact? For example, lactic acid or acetic acid. So here we have the number of the particle per centimeter cube of acid, that's low. And the degree of the ionization for the strong acid, that should be 100%. So D is our correct answer here. In a question number 7, the ionic equation show the reactions of chlorine with the reaction of the bromine, so sodium bromide. So chlorine is coming above, it's a highly reactive as compared to the bromine. So if we combine the mixture of the chlorine with the sodium bromide solution, so chlorine will replace the bromine. Why? Because the chlorine is highly reactive as compared to bromine, and they both belongs to the group 7 in periodic table. So this way, the chlorine and the sodium ion and bromine ion, and they're going to produce of the bromine gas and sodium and chlorine ions. So here a question, what is the simplest ionic equation for these reactions? If you define about ionic equation, so dissolved ionic compound are written in a separate ionic form. That's number 1. And number 2, the equation should be in a balanced form. So that will be your correct answer here. When we see then A, so that sodium bromide and sodium chloride, they are not in ionic state. So that's why it is not correct option. What about B? They are written in an ionic state, but that's not a balanced equation. For example, if you can see that the chlorine and the reactant are 2 atoms in a molecule. What about in product? There is 1 ion, so that's why it is not balanced. In the same way, the C is in ionic state, but that's not balanced equation. What about D? So the 2 atoms, they're present in 1 chlorine molecule. They react with the bromine ion and produce the bromine. So the bromine will convert from ionic state into the atomic state and then convert into a molecule. So this is bromine. So that's written in the ionic state, number 1. And number 2, it is balanced equations. So D is our correct answer here. The next question is a diagram show the reaction of a hydrogen react with the oxygen and produce water molecule. So here, 2 hydrogen molecules, they combine with 1 oxygen molecule, and that produce 2 water molecule. Now, in this way, the total energy consumed during breaking the bond between hydrogen and oxygen, that is 1,368 kilojoule per mole of energy. So that is the energy in during the reaction. What about the energy releases when the bond forms? So how many bonds are forming between hydrogen and oxygen? These are 4. What about the total energy change is minus 484 kilojoule per mole. So this is an overall exothermic reactions. What is the bond energy for this oxygen and hydrogen bond here? So first we see that the formula, the energy change is equal to the energy in minus energy out. So in the reactant, energy is absorbed, and that's an endothermic reaction. What about in product? When the bond are forming, that's energy is releasing. So when the energy is releasing, so we can represent it in the minus in figure. What about the energy is absorbed? We can represent in plus in figure. So we can see in the number, so energy in, that's 1,368 minus the energy out is not given in the question. So here, let's suppose we consume hydrogen and oxygen is X. So there are 4 hydrogen and oxygen covalent bond. So we can represent minus 4x is equal to overall changes minus 484. Now, in this way, you can see that the 1,368 is plus in one side, other side, and that will be subtracted. These two numbers in minus, so they will add with each other and produce 1,852. What about the 4 is multiplying? Minus 4 is multiplying with the x. Other side, it will divide minus 4. And minus minus will subtract, cut, and that will convert the plus. And 1,852 divided by 4, our answer will be 463 kilojoule per mole. So that will be our A is our correct answer here. The next question is about the pH value. The solution has the pH of 3. This solution is diluted with water by the factor of 1,000. What is the pH of this solution after dilution? So we define the pH is what? That is the negative log of hydrogen ion in a given solution. So we have, if we have a 1 liter of a solution, so if there's 1 mole of water molecule, so how many number of hydrogen ion are present? So that's our what the negative log of hydrogen ion in a 1 mole of the solution, so or 1 liter of the solution. So this will be our pH value. So we define pH value as what? Negative log of hydrogen ion concentrations. Now the pH in the question is given pH is equal to 3. So the hydrogen ion concentration will be 10 raised to power minus 3. If we convert this 10 raised to power minus 3, that is equal to the negative log, like mean pH value, pH is equal to 3. So that's the same thing. Now here, the dilution, if we dilute this by factor of 1,000, so factor of 1,000 mean 10 raised to power minus 3 divided by 1,000. So that will become 10 raised to power minus 6. So this value, when it will become 10 raised to power minus 6, so hydrogen ion will become 10 raised to power minus 6. So if we once again apply the negative log at the both side, so pH mean is equal to negative log of 10 raised to power minus 6, the answer will be equal to 6 here. So D is our correct answer here. What is the definition of a mole? So this is knowledge-based question. You should know the correct definition for a mole. So the correct definition for a mole is what? The 1 mole contain 6.022 into 10 raised to power 23 number of particle. So any element or molecule, so which 1 mole of any atom or any atomic substance or molecule or ionic substance or compound, they contain the number of particle of 1 mole is equal to 6.022 into 10 raised to power 23. So B is our correct answer here. We have completed the first section, so we're going to proceed to the second section. That's our section B. So there are structured questions here. So fullerene are allotrope of carbon that have many uses. In a figure 11.1 show the molecule of fullerenes. Now these molecular fullerenes, you can see each carbon contain 3 bonds around. And these fullerenes, they are in hexagonal and pentagonal in shape, and that's our in ball-like structure. Now we're going to see the question, which group of the allotrope contain this fullerene? So these fullerenes, the allotropes are what? So the element which contains same chemical property, but the arrangement of the element or the atom in a structure are different. So that's why it has a different physical property. So, or on the basis of the different arrangement, for example, we have graphite or fullerene or buckyball or diamond. They all consist of the carbon. So they belongs to organic form of allotropes. So they consist of the carbon and the macromolecule. So if this consists of the carbon and derivative of macromolecule, so that's why these allotropes belongs to organic compound. The next question is, what is approximate size of the molecule of this fullerene? Here, to get an approximate size, that's a knowledge-based question. You need to learn by heart that that is 1 × 10 raised power minus 10 meter. So that's a knowledge-based question. So this will be your correct answer. The next question, the carbon atom in a fullerene are joined by covalent bond. So these different atoms which are present in a fullerene, they are connected by a covalent bond. So explain how two atoms of carbon form a covalent bond. So that's the 2 mark, and you need to describe the carbon atom. They share a 1 pair of electron between them. And this shared pair of electron, on the basis of this shared pair of electron, they attain their nearest noble gas electronic configuration. And that is what the outermost electron should be 8. For example, these 2 carbon, they are sharing a 1 pair of electron from each carbon. And if we count the outermost electron in each carbon, they become 8. So 2 atoms of a carbon, they share a 1 pair of electron and get the stable electronic configuration. So that will be your correct answer. How many covalent bonds does 1 atom of carbon form in a molecule of fullerene as shown? So as we studied about the structure of a fullerene, the structure of 1 carbon contains 3 covalent bonds around. So you can see in that structure, the model used to show the molecule of fullerene in a figure has certain type of limitations. The table shows some of the statement about the model. Which statement about this model is true or false? For example, what type of information what we can get on the basis of this model? For example, it shows the length of covalent bond. So we cannot get this type of information from the model. So that's why it is false. It shows the size of carbon. So we cannot see the size of carbon from this model. What about it shows 3-dimensional shape of molecule? So these 3-dimensional arrangement, we can also see that it's a ball-like structure. So that's this type of information is correct. So that is true here. So we can see by observation of fullerene molecules, so we cannot see that the bond length, we cannot see that the size of the atoms, but we can observe about overall arrangement of the molecule. So in this way, overall arrangement, that's in the ball-like shaped structure, and these are pentagon and hexagon shape, they are in arrangement. So that's our correct option here. So we cannot observe the size of the carbon, we cannot observe the length of the bond, but we can observe the 3-dimensional arrangement of molecule here. The next question is, fullerene can be used as a lubricant. This lubricant reduces the friction between the moving part. So in a figure 11.2 shows that lubricant being sprayed onto the chain of motorbike. For example, we want to reduce that frictions between different parts. So to reduce these frictions, we are using as a lubricant these fullerenes. Now explain why the fullerene can be used as lubricant. Use this idea about the structure of a bonding of fullerene. So if we see that the bonding structure of the fullerene, so the attractive forces between the molecule of fullerene are very weak. So that's why these fullerene molecule can easily slide past each other, and they provide lubrication between the two surfaces. So that's your correct answer. So number 1 key point is what? There is a weak intermolecular forces between the fullerenes, and that's why they can slide past upon each other, and they provide lubrication or reduce the friction between the two surfaces. So that will be your correct answer. A lubricant may need to be used at a high temperature. So explain why the fullerene can be used as a high temperature. So use idea about the structure and the bonding of fullerene in figure 11.1. So what is the structure importance of the fullerene? Like how we can use it at a high temperature. So the first thing, the fullerene consists of many covalent bonds. These many covalent bonds make the fullerene structure more stronger. So it has, if there's the internal structure or intramolecular, the forces in the fullerene, so these are more stronger because it contains so many covalent bonds. And due to this, so many covalent bond, internal structure is more stronger, so it has high melting point. So it can withstand with a high temperature and its structure stays stable. So that's why at a high temperature, it can easily provide the lubrications. So that's why we can use the fullerene even at high temperature. We're going to proceed to the next question. So question number 12, the potassium chloride is an ionic compound. So there is the potassium that belongs to the group 1 in periodic table, while chlorine belongs to the group 7 in periodic table. So it is made from the potassium, that's our the +1 oxidation state, whatever the chlorine is -1 oxidation state, and explain why the potassium is found in a group 1 of a periodic table. So in a group 1 in the periodic table, all elements contain 1 electron in their outermost shell. So potassium is also contain 1 electron in their outermost shell. So that's why it is present in group 1 in periodic table. So question number B here, explain how an atom of potassium react with an atom of chlorine to make potassium chloride. So here we need to describe or we need to explain how ionic structure form. So here we have potassium atom. This potassium atom that lost 1 electron, while the chlorine atom gained 1 electron. Why? Because the potassium belongs to the group 1, outermost electron is 1. So it will lose 1 electron to get the stable electronic configuration. What about the chlorine belongs to the group 7? So it contains 7 electron in outermost shell. So it will gain 1 electron to get it octet rule. So that's why potassium lost 1 electron, while the chlorine will gain 1 electron. And in this way, the potassium will contain positive oxidation state, while the chlorine will have a negative charge on that. And there's electrostatic force of attraction between these oppositely charged ions that form potassium chloride. So that will be your 2 marks here. The next question is a student electrolyzes the potassium chloride. The diagram show an equipment. In this equipment, we have the battery, and this battery is connected with the 2 connection. One is with a positive that's connected to the 1 electrode, and second negative is connected to the another electrode. What about as electrolyte? We are using solid potassium chloride. What is the problem in this apparatus? In this apparatus, the wooden splint are used as an electrode. Now, these electrodes should be conductor of electricity. So that's why the electricity can pass through. So these are non-conductor. So that's one issue. The second problem is we use solid potassium chloride. Now, this potassium chloride is an ionic compound, and ionic compounds do not contain free electron, and they do not contain free ions. So that's why these are non-conductor of electricity. So the question is, the student experiment does not work. So describe and explain the 2 ways the student could change the experiment to make it work. So first thing, we need to change the wooden splint into a conductor graphite, which can conduct electricity. And number 2, the ions are not free to move in a solid form of potassium chloride. So we need to dissolve this potassium chloride in a water so that the ion can easily flow through it. And in this way, this will conduct electricity. So these are 2 changes we can make, and that will be our correct answer here. The question number D is a successful electrolysis of potassium chloride and potassium is made a cathode. So explain how the potassium atoms are made from potassium ions. So we can see that what is happening in this electrolysis of potassium chloride. So potassium is losing one electron, and after losing this electron, this will get what? One positive charge. So when it will get one positive charge, so this will be attracted toward cathode, which contain negative charge, and it will move to the cathode and gain one electron. And that convert into atomic state. And after converting into the atomic state, it will deposit on the surface of cathode. In the same way, this is not related to the question. So at anode, what is happening? The chlorine will go at the anode that will lose extra electron and convert into the gas state, and the bubble of chlorine will release at the surface of anode. But the examiner asking question related to the cathode, what is happening with the potassium? So we can see these potassium ions are positive, so they are attracted toward the cathode, where they gain extra electron. So after getting these electrons, each potassium ion gain one electron at a cathode and reduce into an atom. So this will gain one electron, that will reduce and convert into an atomic form, and that will deposit on the surface of cathode. We're going to move to the next question here. The hydrogen can form a compound with the group 7 atom. So there's a group 7 element. They contain 7 electrons in their outermost shell. So these compounds are simple covalent molecule. For example, hydrogen react with chlorine and that produce hydrochloric acid. So when the simple covalent molecule are heated, they thermally decompose back into their element. So in this way, for example, if you take a hydrochloric acid and we heat it, and once again, it will convert into a hydrogen and chlorine. And another way, the hydrochloric acid is also a strong acid. If you put it in, if you dissolve it in water, and this will convert once again into their ions. So that's reversible reaction. For example, they react and they produce hydrochloric acid. If you further heat it, it once again convert into the hydrogen and chlorine. Now, this table show some of the information about these compounds. So first table is showing about if we move in a group 7 in periodic table, from fluorine, chlorine, bromine, and iodine, so electronegativity decreases down the group. So that's the general information we should know about. Second, information is given if you're moving from hydrogen chloride to the hydrogen iodide. So hydrochloric acid to the hydrogen iodide. So the boiling point is increasing down the group. Second, a thermal decomposition energy is decreasing down the group. So this is your description. What about in a second table? It's showing when you see in a second table here, so you can find some information. If you're moving from hydrochloric acid to the hydrogen iodide down the group, so you can find the size of molecule is increasing down the group. What about the strength of covalent bond is decreasing down the group? So you need to describe the information, what is given in the table. And after description, you need to explain or you need to give a reason, a scientific reason behind. For example, if you make a one statement, if you are going from hydrochloric acid to the hydrogen iodide, so the boiling point is decreasing. Sorry, that the boiling point is increasing. So that's your one point. Now question is why it is increasing. So the reason is what? So by moving from hydrochloric acid to the hydrogen iodide, the size of molecule is increasing. So by increasing the size of molecule, so the intermolecular forces are also increasing. And by increasing the intermolecular forces, the more energy is required to boil the molecule. So that's why the boiling point is increasing. So this will be 3 marks. You need to describe what is given in the table, and you need to explain or give a reason for that. The next is if you're moving from hydrochloric acid to down the group, so the thermal decomposition energy is decreasing. So the reason is what? If you're moving down the group, the bond strength is decreasing. So if the covalent bond strength is decreasing, so less energy is required to decompose them. So that's why that's one of the reason. The second reason you can also give the reference, for example, if the size of molecule is increasing and the bond strength is decreasing. So that's inversely proportional relationship. So we're going to see that on the basis of this given information, this type of the answer you can write. So we are making a one argument. The size of molecule and the boiling point increase going from hydrochloric acid to the hydrogen iodide. So the boiling point involved in the breaking intermolecular forces. So as the size increase, the strength of intermolecular forces also increase. So the stronger the intermolecular forces, you need more energy to break them. So that's your one point you're writing and you're explaining your answer. The second point is thermal decomposition decreasing going from hydrochloric acid to the hydrogen iodide because the bond strength decreased from hydrochloric acid to the hydrogen iodide. So the temperature required for thermal decomposition also decreased. So that's your reason. Further, you can make an extra point here. Smaller the molecule, have shorter the covalent bond. So if there's a shorter the covalent bond, so that has a greater force of attraction of electron to the nucleus. So that's why more energy is required to break them. In the same way, if there's a larger Oh, sorry for interruptions. So we have done this question. So you can write a first and second that will secure your full marks. You can also put an extra point here, and these are the red points. So you can also build an extra point for this answer. We're going to move to the next question here. That's the calcium is a metal found in the group 2 of a periodic table. So draw an arrangement of the electron in atom of a calcium. So you can see, and the calcium atom is an atomic number that's 20. So we can arrange it in a 2, 8, 8, and 2. So then in the first shell, there will be 2 electrons, and in the second shell, there are 8 electrons. You can draw it by 8 cross. In the third shell, there are 8 electrons, and in the last shell, the remaining are 2. So that will be 2 electrons. How I know that? I will see in the periodic table. So the atomic number is 20. So it means the 20 number of proton and same number of electrons are there. So you need to arrange these electrons in the first shell, always contain 2. Second shell contain 8, if there's a possible. Now third shell contain 8. It's a possible because it's coming 2 plus 8, 10, and plus 8 is 18. Now remaining is 2. So the outermost shell contain 2. So that's why it is present in group 2 in periodic table. So here we have done that. The next question is the calcium is a metal which can conduct electricity. So describe the structure and the bonding in the metal and explain the metal can conduct electricity. So you can also include the diagram in your answer. So I drew the diagram here for you. So this diagram you can draw. So there are the metal atoms, so which are losing extra electron in their outermost shell. So that's why you can see a pool of electron between the metallic ions. So these delocalized electrons, they are present between the metallic ion and they have a force of attractions to these positively charged metal ions. And this force of attraction is making metallic bond. So these a lot of free electrons, they are present between the metallic ion, so which are available to conduct electricity. So there will be 3 marks. First is you need to draw metallic 8 ions in a positive state. If it will be more closer, that will be better in that structure, but you need to put a delocalized or a lot of free electron in between them. That's your second mark. So, and their charges should be correctly present. That's your third mark. And further, you need to describe this structure. So metal consists of a joint lattice of a positive ion, which are surrounded by delocalized electrons. So the electron which are present between the two atoms, which have a force of attraction between them. So these are delocalized electrons. So these delocalized electrons between metal ions are free to move, so they can carry the charge or current. So these free electron moving make the metal as a good conductor of heat and electricity. So these points you can bear to secure the full marks here. The calcium react with the water to form the solution of a calcium hydroxide and the hydrogen gas that will produce. So if you put that the calcium, this will react with the water. So any metal who will react with the water or that is producing, if there's any metal that's reacting with the acid, that's producing a hydrogen gas. What about that calcium when it will react with the water in a solution? So that will produce calcium hydroxide and produce hydrogen gas here. So write the balance symbol equations to the reaction of a calcium with water. So you need to write about the symbol for calcium that we are taking in a solid form, plus we are taking a water molecule, and that's producing calcium dihydroxide plus hydrogen. You need to balance, first you need to write the correct formula. For example, the correct formula for water is H2O. And the correct formula for calcium hydroxide, that is the CaOH. And the hydrogen is present in a molecular state. And after that, you need to put these, the equation. For example, you need to balance the equation. For example, we have the hydrogen here, 4 in the product. And in the reactant will be 4. So 2 multiplied 2, that will become 4. So first you need to write a correct formula, and then you need to balance that, the equations. A solution of a calcium hydroxide is also called a lime water. So name the gas lime water is used to test for. So we are using the lime water to test the presence of carbon dioxide. So when we pass that, the carbon dioxide from lime water and this convert into calcium carbonate and that change the color milky. So this is indication that the carbon dioxide is present. So carbon dioxide is our correct answer here. Now, 250 centimeter cube of solution contain 1.88 gram of calcium hydroxide. So if there's the mass of calcium hydroxide is given there and the volume in centimeter cube is given there. So you need to convert this volume in the liter by multiplying by 1000. So calculate the number of mole in 1.88 gram of calcium hydroxide. To find the number of mole, you need what? The mass over molar mass. Now here, the mass is given, that is 1.88 gram. But what about the molar mass? You have to calculate it. For calculation of a molar mass of calcium dihydroxide, so CaOH twi. That is CaOH twi. So now the calcium is given there, that is 40.1. If it is not given, you can also get from periodic table, that value will be 40.1 relative atomic mass. Plus the oxygen is 16, and plus the hydrogen is 1. And hydroxyl group, there are 2 molecules, so that's why I'm going to multiply their collective figure by 2. So answer will be 74.1 is a molar mass of calcium dihydroxide. Now, if to find the mole of the calcium dihydroxide, so we're gonna divide the mass over molar mass. So mass is 1.88 gram divided by 74.1 gram. So our answer will be 0.02537. So two significant figure, this will give us answer 0.025. That will be our correct answer here. Use the answer in a part 1. So we got the answer in the part 1 to calculate the concentration of a calcium hydroxide in a solution. To calculate the concentrations, so we need the mole over the volume. And the question examiner is giving, we need to calculate the volume in dm cube. What about it's a given value is in cm cube? So that's why this answer we will multiply into 1000 to convert centimeter cube to the decimeter cube. So concentration of the solution, the formula is equal to the number of mole divided by the volume. And if you want to convert it from cm into the dm, so multiply by 1000. So we got that the number of mole, that is 0.025 divided by 250 centimeter cube, multiply into 1000, and we will get our answer 0.1 mole per dm cube. So that's our correct answer. So we're going to move to the next question here. A student ate an excess of dilute hydrochloric acid to a solution of a calcium hydroxide. So if we ate an acid with a base, so you know what will happen that, so acid will neutralize the base here. So write the balance equation, balance ionic equations of reaction of a dilute hydrochloric acid and the solution of calcium hydroxide. So we're going to write about the dilute hydrochloric acid balance equation, ionic equation. So this balance ionic equation is what the hydrogen that's released by hydrochloric acid. What about the hydroxyl ion released by the calcium dihydroxide? They neutralize each other and produce a stable water molecule. So that will be our balance ionic equations. What about the rest of all? For example, the chlorine and 2-chlorine, they will react with the calcium and that produce the calcium chloride salt. But here we are supposed to write up the ionic equation. So these two ions will neutralize each other and produce a water molecule. So that will be our correct answer here. Describe and explain how the pH of the solution of the calcium hydroxide changes as the dilute hydrochloric acid is added until it is in excess. So for example, if you're adding the acid with the base, so they will neutralize each other. So a neutralization reaction between the hydrochloric acid and calcium hydroxide decrease the pH value. So this pH value is first is placed in a above than the 7, that's in basic state. This will decrease to the 7, so the concentration of the hydrogen ion increase in solution. So, and in this way, if there's a concentration of the hydrogen ion are increasing, and in this way, the acid value is increasing, so the pH value will go less than 7. We're going to move to the next question here. The color changes can be used to show that oxidation and reduction reaction happen. So a diagram show the reaction between that's the acid solution of vanadium oxide and the zinc. For example, in the conical flask, we are taking the solution of vanadium oxide, and this solution of vanadium oxide with acidic solution, so that will reduce and change color. What about the reducing agent? We are using a zinc. So zinc will release the electron and that will oxidize itself and reduce the solution of vanadium oxide. Now, as the reaction happens, the color of the solution turn from blue to green. So you can see above here, for example, vanadium is placed in an oxidation state 3, 4, and 5. So relevant to this question, vanadium in an oxidation state 4, so that is in blue in color, while when it will turn the oxidation state 3, so this will turn into green in color. So it means when the vanadium will reduce, so that will take electron, so that will turn into green in color. Now here in this equation is given there. So vanadium oxide and plus a hydrogen came from acid, and these electron, they came from zinc, and that will produce the vanadium with a +3 oxidation state and plus water molecule. Now the students think that the half equation shows that reduction had been taken place. So this reduction has been taken place. So how we can assume that reduction reactions should be taken place? So with the reference of this equation, we can see the reaction involve loss of oxygen from vanadium oxide. So you can see in the reactant, the vanadium oxide that contain oxygen. What about in product? The oxygen is moved away from vanadium. So that's why the vanadium is reduced. The second statement we can build, the reaction involving the gain of electron by the vanadium. So the oxidation state, if changes in vanadium, is +3 oxidation state. So that's why there is a gain of electron. So that's why the vanadium is reduced. So it converts the blue color to green in color. So that's our correct answer. We're going to move to the next question here. The Hopf equation shows the reaction of a zinc. So we need to write, for example, the zinc is a reducing agent and it will oxidize itself. So the zinc, they will lose 2 electron. So if it is a losing 2 electron, so that will get the +2 oxidation state. So if that's a losing 2 electron. So if the zinc is going to lose 2 electron, and after losing 2 electron, the zinc will get the +2 oxidation state. So that one, sorry, I'm gonna make it a bit sharp. This is going to be +2 oxidation state. So why there is the +2 oxidation state? So if it is a losing 2 electron, and after losing this 2 electron, so that will oxidize, and that is containing the +2 oxidation state here. I'll complete the Hopf equation. So here we have done that. A student removed the zinc from the green solution by filtrations. Now, when they add some nitric acid to this solution, it turned black. It turned black from green to blue. So before it was reduced. Now, if you're adding the nitric acid, once again, it will oxidize. So that's a converting from green to blue. So green with the +3 oxidation state, and if you add the nitric acid in that, and this will oxidize into +4 oxidation state. For example, this is the losing the electron, and if it's the losing 1 extra electron, and this will get the +4 oxidation state. So once again, it will convert from green to blue in color. So we can see that the nitric acid is working as an oxidizing agent. So vanadium lost electron, and that will convert from vanadium +3 oxidation state to vanadium +4 oxidation state, and it will get oxidized. So that's the correct option here. So if you feel any problem relevant to any question, or if you did not understand any point, so you can also put in the comment box. So I'll try to answer that question. Hopefully it will be helpful for you. Thank you. Thank you very much.